everyone, I am Kim Armentiano, and for today we were going to learn about organizing data. It is very important for us to learn how to organize data. So when we organize data, we'll be able to see how to really gain insight as to what the data is telling us. So considering how large data set can be overwhelming, right? So that's one of the very basic principle when we have a lot of data. Then we can't really gain any insight about the data that we have. So if we learn how to organize it in a way that, or in a best way possible, we will be able to gain more insight and we will be able to tell what the data is telling us. So we need to organize data into smaller interval, and we're going to do that today. In statistics, this is usually done by organizing data into smaller intervals or classes. When we then count how many data value fall into each classes. So this is what we call a frequency table. So we're going to see what frequency table is later, but a frequency table is a way of organizing data in such a way that is partitioned into classes or intervals. So we will see later on there's been a classes or interval wherein one that data will fall into that bin or into that range of data or number. Then we will be able to classify as part of that. And then we're going to count it as one of the frequency for developing our frequency table. So this is our way. We show how data values are in each classes, and the class of the intervals are constructed so that each data value falls into exactly one classes. So we have here the example data. It is a test scores of 30 students in a quiz. So we have 11, 35, 28, 18, 16, 21, and so on. So it's not organized in a way that we can really gain insight. It could not even tell what is the highest value here. So we need to organize this so that we will be able to gain insight that the data we have. So alright, let's proceed now to its specific steps. So in terms of steps, you first need to identify how many classes you want to have. So as a rule of thumb, it should be 5 to 15 classes. So why is this? So it's because if you have less than 5 classes, you will take the risk of losing important insight from your data. If it is more than 15, the data may not be sufficiently summarized. So second, find the class width for the class. So what is class width? So class width is the difference between the lower class limit of one class and the lower class limit of the next class. So when we say lower class limit, it is the lowest data value that you can fit in the class. And on the other hand, upper class limit is the highest data value that can fit in a class. Okay, now how do we compute the class width? So we have here upper limit value minus lower limit value over the desired number of classes. So first, we need to look at our data. So in our data, look for the largest data value and look for the smallest value. So from the given sample data, I already arranged it from the smaller value to the highest value. So we have here. So now we can easily see the upper class limit value is 48 and the lower class limit value is 11. So in this case, we decided that we're going to have 6 classes. We can also have 7, 8, 9, 10, 11, 12 to 15. But now we will use 6. So let's compute. So 48, which is our upper limit value, minus 11, which is our lower class limit value, is 37. Divided by 6 is equal to 6.16. And then increase the computed value to the next whole number and it makes 7. So our class width is 7. So in our frequency table, we have our class limit that is lower to upper limit value. So take note that class width is 7, so the distance value of the two number is 7. So we can see here in our given class limit value that the distance from the lower class limits to the upper limit value is 7, and that's what the class width does. It makes sure all the classes stay in the same size. So the first group is the lower class limit value, which is 11, and the distance between two numbers is 7. So we will count it starting from 11, which is our lower class limit value. So the value of the first group are 11, 12, 13, 14, 15, 16, and 17. That makes 17 the upper limit value of the first group. So the next number of the upper class of the first group will be the lower class of the next group, and that is 18. And then count again starting from 18, that makes 24 the upper limit value of the second group. So continue doing that until we get the value of the 6 classes. So to make it simple, we will just subtract our class width by 1, and then the value of that we will going to add in our lower limit value. So for example, we have here 7, the value of our class width, minus 1 equals 6. Then let's just simple add the lower class limit value in 6. So 11 plus 6 equals 17. That make the first group 11 and 17. And then get the next number of 17 as the lower class limit value of the next class, which is 18. Then plus 6 equals 24. That makes second class is 18 and 24. And then get the next number of 24, that is 25, and then plus 6 equals 31 to make the next class be 25 and 31. The second thing to do in making a distribution table or the frequency table is to identify the frequency of each classes, and it can be done by tallying process. Like for example, in our data, so 11 is falls into the first group, which is 11 to 17. So we will put 1 mark in the first class, which is the 11 and 17. Then 35, which is in between 32 and 38. So we will also put 1 mark in that class. And then 28 is in between 25 and 31. Let's also put 1 mark in that class. If you've done tallying all the example data, you will just count the marks, how many marks that classes have, and that is the frequency of that class. But if you already arrange the sample data as what I do earlier, I won't do the tallying anymore. Instead, I will just count from the lower limits to the upper limit value. So for example, the first group is 11 to 17. So let's count how many number that is value is 11 to 17. So from the data sample that we already arranged, we have 11, 11, 12, 12, 12, 16, and 17. So the first class has a frequency of 7. So the next one is 18 to 24. So we have 18, 19, 21, 21, 24, 22, 23, 24. So the second class has also a frequency of 7. So next is 25 and 31. So we have 26, 27, 27, 28, 29, 30, and 31. So that class has a frequency of 8. And next, 32 to 33. So we have 32, 33. No, 32 to 38. So we have 32, 33, 35. So that's all. 3 frequencies. Next is 46 to 55. No, 39 to 45. So we have 39, 30, 44, and 44. So that class has a frequency of 3. And last is 46 to 52. So we have 46 and 48. So the last class has a frequency of 2. So if we have just only the class limit value, we cannot call it a frequency table, but it is only a class. Then if we have the frequency of in each class, then it is a frequency table. So to make sense of the information that we have, this is more understandable and it's giving more insight. In order to create a graph of this frequency, let's identify the relative frequency in each classes. And now, let's talk about on how to compute relative frequency. So the formula of this problem is frequency or relative frequency is equal to the class frequency over the total of all frequency. So the total number of our frequency is 30. Then let's divide all our class frequency in 30. So here in our first class, we have a frequency of 7. So divided by 30, that makes the relative frequency 0.23. So that means 23% of students get that score in a range of 11 to 17. So the next class has also a frequency of 7. So it also have 23% of students that get a score in that range of 18 to 24. And the third class has 26% of students got score in a range of 25 to 31. So generally, 23 students got a score from 11 to 17. And also, 23% of students got a score from 18 to 24. Then, 26% of students got 25 to 31. And the next 10% of students got a score of from 32 to 38. And then also 10% of students got a score from 39 to 45. And last, 6% of students got a score from 46 to 52. To make our data to be more organized, I have here a graph. I don't know what's the name of this graph, but I think it is a line graph. You can see here clearly that only few students got a score from 46 to 52, and there are more students that get a score in a range of 25 to 31. That's all for today. Thank you for listening and goodbye.